Okay, our final problem. Let's take a quick look at it. I'll snip it. Try to put it in here as quick as I can before some reason I lose my... I got it. Okay. Okay, so coefficient of restitution. Um, we're going to take a look at that. And coefficient of restitution, he has lectures on that, but that is actually... This is the way I remember it. The 1 and the 2 versus the 1 and the 2. And one is after impact, one is before. Um, here's the way I like to remember it. You have a basketball. It comes this direction. Say right before impact, the velocity is equal to 10. And then let's say it comes off and it goes velocity equal to 5. There's the basketball coming off the ground. So it lost some energy in its impact. Let's solve this the Earth. So the basketball is so small compared to the Earth. We're going to label this as 1. We're going to label this as 2. So velocity to initial is equal to velocity to final equals to nothing. Now the question is, this is the initial and that's the final. So which one goes on top? First of all, this doesn't even change. The Earth's velocity doesn't change. So you end up with minus v1 over v1. One has to be initial and the other one has to be final. Which one? First of all, coefficient of restitution exists between 0 and 1. Positive number. So therefore, what happens is, let's call this to be positive as far as the velocity is concerned. That means this needs to be the initial and this needs to be the final. Turns out, let's go ahead and put the F and the F and the initial and the initial. Turns out this is a minus 5. This is a 10. So the coefficient of restitution in my example is a half. But let me see if I can go in and judiciously take these little x's out. And so this is the form of the equation, and the way I remember is always think back to like a basketball or something bouncing, coming off the ground with less velocity than it did before. If it's a basketball that has no air, it just simply stops and doesn't bounce off the ground. If it doesn't bounce off the ground, it's 0. So if it's the perfect elastic that no energy is lost in it, it will come off at the same speed. And you'll get a coefficient of restitution of 1. So this is losing most all your energy in that situation. This is losing none. And you're halfway in between most of the time, or not exactly halfway, but somehow in between. Let's take this now and just delete it. We went over the example. I'm just going to put this here. Okay, so it impacts a metal surface. If the initial velocity of the thing is 3 feet per second, straight down, and the coefficient of restitution is that, what's the expected speed and direction of the ball after impact? So I'm going to call this 1. I'm going to call this one 2. Here's your thing. E, 0.85 equaling to. Now, here's the big key. Your coordinates. This is the... Okay, hang on. Let me see if I can do this. So this is the plane of impact. This is the line of impact. Now let's look at this and think about this. So this means I've got to break this 3 meters per second. Let me get real close to it. I got to break this 3 meters per second. Here, I'll put the 2 right in there. Got to break this 3 feet per second into components. So if I'm going at 3 along here, I'm going a certain amount this way. I'm going a certain amount that way. Okay, as it turns out, that's 25. Let me see if I can move up. So if this were 3, okay, let me redraw this. Oh no. Okay, let me see if I can redraw this without maybe using a, here, I'll use a blue. Okay, so in other words, that was a value of 3. This would be 25. This would be 3 cosine 25. This would be 3 sine of 25. Okay, so M1 V1 plus M2, which is the basketball, V2 equals to M1 V1 plus M2 V2, where this is the initial and this is the final. So first of all, we're going to make a big assumption. The metal plate doesn't move. So this means M2 V2 along the impact, and this is a biggie, initial is equal to M2 V2 final along the impact. Because we're just going to assume that thing doesn't change at all. So I'm going to pause this for a second. Okay, this one has a conflict kind of, because actually, here's what happens. Okay, he didn't give enough information. So the momentum says V2 initial is equal to V2 final. That can't really be. So it turns out that doesn't sort of compute. So it turns out that you can't necessarily assume these two, and that leaves you with not being able to do this, and it leaves you only with this equation. However, in this equation, it is legal to assume that the plate doesn't move. I know it's a conflict. It doesn't make sense, but there wasn't enough information like the mass of this nor the mass of that. The initial velocity back and forward. It's okay. We're just going to go into here and assume we lost energy. So V2 final over V2 initial. Turns out V2 initial along the impact V2 final 3 cosine 25. So V2 final is equal to 85% of the initial impact onto it. So what it turns out, and you have to remember there's a minus sign, so it's actually the other direction. So let's look at this from this viewpoint. Okay, and I can go ahead and zoom in here. And what I'll do is I'll go ahead and take that pen and change it to a different color. So it comes off this point right here. Okay, after impact, it turns out this 3 sine of 25 is maintained. So this is not along the impact. This is perpendicular to the impact. So you just simply copy that off. The problem is now you've lost some energy. So instead of having this here, as I've done, oops, see if I can judiciously get rid of this. I'll leave that there. This gets drawn down, and component coming back off is 85% of 3 times cosine of 25. So this is still 3 sine of 25. The other is 3 cosine of 25, but 85% of it because they're coefficient of restitution. So in fact what happens is I lost energy coming directly off the surface, but not perpendicular to the surface. These remain the same. So how do you find this angle? Well, it kind of relates to finding, say, that angle. And you can take the tangent of this versus that, the ratio of those, and take the tangent. Once you have that angle, then you know this is 25. If I remember, yep, this is 25. So all you do is you take whatever angle you find here, subtract 25 from it, and that should be your answer. So with that, I'm going to go ahead and stop this whole thing, and go from here. I just put this problem here. It's one that's not as realistic. You can go in, and if it bothers you, he has, I believe, a problem that, let me see. No, it was maybe the one before. Was it this one? I could have swore I saw a problem like this. Maybe I didn't. Surface. Oh, here we go. I would say go look at this one. Here's one coming at an angle coming off. Here's one very much like that. I would take a look at this one. There are some things wrong with this that are very bothersome, but to me, but they work out okay, and that's fine. So I would go back and look at those videos. Go ahead and watch this video and then that one, and go on from there. So this one was 14 minutes.